Hello, everyone. My name is Megan, and I am Esip's Community Director. Welcome to this webinar in the 2021 Earth Science Information Partners Innovation Webinar Series, which follows Esip's theme for 2021 of leading innovation in Earth Science data frontiers. We are delighted to welcome today's speaker, Dr. Ryan Mcgranigan, Principal Data Scientist and Aerospace Engineering Scientist at ASTRA Associates. If you're not familiar with Esip, welcome, and I'll give you just a two-slide introduction to what Esip is and why you might want to continue to participate in our organization. First of all, we're really glad that you're here. Esip strives to be a leader in promoting the collection, stewardship, and reuse, as well as use of Earth science data, information, and knowledge, and to be responsive to societal needs. For more than 20 years, Esip has helped members of the Earth science data community to find each other across traditional boundaries, to leverage each other's expertise, and to work together on common data challenges. So to help Earth science data professionals work together, Esip fosters rich collaborative experiences, including numerous community-driven virtual collaborations, the Esip Lab, which supports the development of innovative applied Earth science technologies, and through 2 annual conferences. The next meeting will be in January. It will be online. Our agenda often includes upwards of 50 community contributed breakout sessions on a wide range of topics, including but not limited to data stewardship, geosemantics, cloud computing, AI, and machine learning, as well as multiple plenaries and numerous networking opportunities. We encourage you to join us for the meeting and to consider submitting to the call for sessions, which will be released very soon. So that brings us to today's webinar. Again, we are excited to welcome Ryan Mcgranigan. Dr. Mcgranigan is the Principal Data Scientist and Aerospace Engineering Scientist at ASTRA Associates in Boulder, Colorado, where he leads data science and machine learning efforts to improve our understanding of the Earth's space environment. Excuse me. Ryan began this role after completing a Jack Eddy Living with a Star postdoctoral fellowship at the NASA Jet Propulsion Laboratory, during which he studied the Earth and solar system planets' interactions with the sun. He also works extensively across NASA centers, including Goddard Space Flight Center and JPL. Ryan was selected as a National Science Foundation Fellow to complete his PhD research at the University of Colorado Boulder and completed his degree in Aerospace Engineering Sciences in the fall of 2016. He also holds a master's degree in Aerospace Engineering Sciences from CU Boulder, a bachelor's degree in Aerospace Engineering from the University of Tennessee. Ryan is a passionate communicator and entrepreneur of science. He was selected to give a TED Talk in April of 2015 on the topic of space weather, and he continually strives to move audiences and more effectively communicate science through compelling storytelling and data visualization. His latest passion has been a new podcast called Origins that examines the pivotal moments across the lives of thought leaders from science, art, engineering, and design. With that, I will pass it to Ryan. And a quick note to the attendees, please add any questions that you have to the chat box during the webinar, and we'll address them after Ryan's presentation. Also, Ryan had hoped to make this more of a discussion format, so please be excited and ready to participate during that component as well.
Excellent. Thank you so much, Megan. And just double checking that people can hear me okay. Okay, great. Thanks for the kind introduction. And let me share my slides here. How does that look, Megan? Look okay?
Looks great.
Fantastic. Okay, so good day, everyone. First, I'd like to say a deep thank you to Megan and the entire Esip leadership for the wonderful invitation to speak today and the opportunity to contribute to this ongoing discourse about innovation in Earth data. I'm really honored to be counted among one of the illustrious speakers in this series and hope I can spark your curiosity and indeed a rich discussion today. At any time throughout the presentation, please feel free to stop me. I'd love for this to be very casual and conversational. So if you do have questions, we can talk about them throughout. But really my goal today is to create that rich discussion, to ignite new vistas of conversation and to seed innovation in our community. I will do it around the idea of a knowledge commons, which will allow me to introduce kind of what I've organized as 3 different innovations. The first is recognizing that space and space data are inextricable from what we're trying to do with Esip, yet they're not yet closely linked with Esip data, nor the people from the space industry and space society deeply involved in Esip on a regular basis. The second innovation is a mindset for how we can go to the spaces in between that are required to do this kind of interdisciplinary work. And I like to think of these as the liminal spaces that are in between established fields. And the second innovation is a mindset of thinking in graphs. And I'll talk a little bit more about what that means and how it allows us to connect the different pockets of progress that are existing. And then finally, the last innovation I want to discuss is recognizing that the challenge is not just technical or technological, but it's also a requirement for sophisticated cultural considerations. And I think the concept of a knowledge commons really reveals that we have to combine these technological approaches to knowledge representation with the governance and trust to make a flourishing commons space. So the way that I'm going to approach this today is to present many pockets of progress across the space sciences that we're working on and our efforts to connect them into a commons. And I'm not going to present technical details, though I'm happy to talk with you offline or even during the discussion session as time permits about those, but hopefully it will lead to those beyond this. Then I'm going to bring this to Esip and where it relates to each of you, how it relates to the efforts that are already going on in this community, and hopefully provide fertile ground for discussion. I'll just mention that though I'm the one speaking today, there are many people, indeed entire communities that are involved in this work and that I will share. And it's inherently collaborative and transdisciplinary. And so I want to emphasize the distributed nature of this, and indeed what we're trying to do requires this. So I'm going to highlight areas in our work where we welcome and need broader precipitation. And I'm going to use this icon to kind of signify that to you. So if you see this anywhere in the presentation, that will point you to the idea that we welcome contribution and participation in that component. And I encourage you to kind of get in touch with me after or online to find out more about those opportunities. So I want to begin today with a land acknowledgement. And I choose Washington, DC, because that's where I live, even though the company I work for is in Boulder. I do a lot of work with NASA Goddard Space Flight Center. So I actually live here in the DC area. But I choose Washington, DC as our place for convening for this acknowledgement. And so we acknowledge that Washington, DC is the traditional territory of Nacotchtank, Anacostan, and Piscataway people. And we acknowledge this legacy and find inspiration from this land. You can find out more from the link that I've provided there. By acknowledging territory or land, we may recognize the Indigenous presence as we convene for this webinar series. We each have a responsibility to consider what it means to acknowledge the history and legacy of colonialism in our history as a nation and as a community. We note the privileges we enjoy today because of colonialism, and we strive to not perpetuate colonial futurity. So thank you, and I think that's important. So to get into the meat of today's discussion, I want to begin with a quote that I think is kind of constantly with me. And let's see if I can go to the next slide here. It's from Marcelo Glasser's book, The Island of Knowledge. And he writes, if large portions of the world remain unseen or inaccessible to us, we must consider the meaning of the word reality with great care. And what I mean by bringing this quote here today is that in our sciences and in our work, we form constructs for the domains that we study. Traditionally, these constructs exist within those specific domains and really branch out to the other domains. I think Esip has really wonderful, rich constructs and is an ideal of how do you create structures for those within earth sciences. But I think we recognize now that the space sciences are increasingly inextricable from advancing the science within Esip. And there's a marked lack of the constructs and the semantic technology maturity to integrate the space-based perspective. And I want to introduce that through a quick story. And just to note that this is but one story that illustrates the need for a space-based perspective and the interconnectedness of the earth and space sciences. And there are many others. For instance, I know someone who's active in this community, Robert Rovetto, has an excellent story about space debris and how we track space objects and the importance of the space-based perspective from that angle. But I want to talk about an event that happened in Hydro-Quebec into the power grid in 1989. And this was an event that caused a massive blackout that was catastrophic. And I want to talk about the interconnections between the earth and space science that existed that caused that event and how we would respond to such an event. So if we look a week before this event began, there was a massive snowstorm in this Quebec territory. And under normal circumstances, this would be pretty innocuous, not too much of a threat to the power grid, but it does place a strain on the grid, one that the grid is designed to be resilient to. But in this special circumstance, one day before this massive blackout in the Quebec territory, there was a massive solar eruption. A coronal mass ejection of this massive cloud of energy erupted from the solar storm, the surface of the sun, and propelled towards the Earth. And coupled with this strain that already existed on the grid due to these weather conditions, it pushed the grid beyond a tipping point and caused a blackout, a cascading blackout in this territory that had resounding and reverberating effects that can be traced across the time leading from this event. So afterwards, immediately what happened was the Toronto underground tunnels, where 500,000 people rely on for their daily commutes, were plunged into darkness. In other mobility considerations, radar was cut off during this blackout, and all flights were grounded from this area. So that's an immediate impact to the well-being of society. Hours later, as this blackout continued, people began to be stranded in their locations. So food and water considerations, public health considerations began to be something that needed to be considered. In days into the future, even months into the future, they needed to look at repairing the grid, putting these things back online and preparing them for the future. And so that required millions of dollars to repair the grid initially, and then an upwards of $2 billion investment to update the grid so that it was resilient to this effect in the future. And that doesn't even begin to quantify the millions of dollars in installed business or the disruption to public health. And so what you can see here is that this interconnection between the Earth and space science is very important in actually understanding an event like this, a complex event like this. And in fact, the interconnection is only being exacerbated. Just this year marked a new vista in space exploration, seeing Blue Origin and Virgin Galactic launching travelers into space and things like the NASA's Artemis program. Our technological and physical expansion into space exemplifies the increasing interconnections between the Earth and space environment. However, although our flourishing increasingly depends on our integrations, our data and knowledge infrastructure have remained essentially static for decades and are no longer sufficient to meet our increasingly dynamic information requirements. So the question again is, what is not seen or is inaccessible in the absence of the space-based perspective? Integrating space into Esip is the first innovation that I wanted to drive to today. The question of how we're going to do that or how we can do that leads me to the second. And I want to introduce this with another quote that I really like. And it's from Norbert Wiener and his pivotal work called Cybernetics that I think really changed the ground beneath the way that scientists and engineers and thinkers render the barrier between what is known and how we can know it insignificant. So he writes, the most fruitful areas for the growth of the sciences were those which had been neglected as a no man's land between the various established fields. And so to me, this is the most important question facing us today, that in the face of increasing complexity of our science, as you saw through that story, how do we interconnect the domains that are involved in this and link across them meaningfully? And I think that helps us in navigating the information that exists in our world. And so the innovation that I want to raise with this quote is that we need a new way of thinking to go to these liminal spaces, these spaces in between. And I think I call this thinking in graphs. And I think a number of people on this call are probably very familiar with that, but just as a general introduction to this, what does it mean to think in graphs? In the most simple way, graphs are a collection of connected entities. So a knowledge graph is a different way to represent information, defining the entities or the nodes, as you see here, maybe Da Vinci, and importantly, the relationships between them, or these edges, connection between Da Vinci and Mona Lisa as the artist who created the Mona Lisa. So this is a way of thinking that's a little bit different than how we traditionally operate now. Once you start to think in graphs, you start to see them everywhere, and it's impossible to separate them from many of the things that exist in society. So one of the most common examples is social networks and communities. These are inherently graph structures where different individuals are connected through some means of relationship between them. But we can also think about our communication infrastructure, how we can connect to other people through phone calls, through internet, through things of that nature. We can also look at an example that I talked about earlier, the power grid. That itself is a network. All these interconnected means and infrastructure for providing us power is itself a network. All the way down to how we structure information in our own minds. Neuroscience is uncovering a lot of information about how the mind actually is built on these network technologies. And so we can start to see that these graphs are ubiquitous across society. And so once you start thinking in these terms, it's really difficult to stop seeing these everywhere. And so this leads us to how we apply this to information science in the idea of a knowledge graph. And I like to define a knowledge graph simply as a data integration system that allows information to be searched and discovered by machines and humans. And it's a platform on which intelligent applications can be developed and around which a more cohesive, less siloed community can be cultivated. And so this may seem a little new to you, but I think everyone's actually very familiar with a knowledge graph. You use one every single day. Anytime you type a question into Google, you're accessing one of the world's largest knowledge graphs. And anytime you discover new information, increasing your own knowledge base by clicking through links on a Wikipedia, you're benefiting from this way of representing information. But the knowledge graphs that we rely on in these instances have largely existed in the world of industry and only have been applied to the sciences in smaller, fragmented, or incomplete ways. So the question that really drives me is, what if we had this for our science? And I apologize, these are advancing automatically. But what if we had this for our science? I think this is leading me into how I'm going to present how we're addressing this within the heliophysics domain, or understanding how we in our planets interact with the sun. So what I'm going to do is first share a trio of projects that are building foundations for a heliophysics knowledge network, or a collection of knowledge graphs. And then I'm going to show a network of projects that are emerging, that are bringing together, along with the cultural component, to make a space knowledge commons. And then finally, to conclude this just brief talk today, I will open fruitful ground for discussion about how this structure lends itself to connect the remarkable pockets of progress that exist within Esip to build an earth science knowledge graph and knowledge commons as well. So let's take a quick walk across what's emerging in heliophysics and the space-based perspective. And I'll do that in 3 separate projects. The first that I want to present is a project that was awarded within the National Science Foundation Convergence Accelerator Program. In fact, it was the only space science focused project that was awarded within that program. And it was called the Convergence Hub for the Exploration of Space Science. If you'd like to know more, you can follow this link here and see a little more. But the problem that we were trying to address was to create an open knowledge network for this problem that I presented earlier. How does solar energy and solar storms and space weather impact the power grid? And the reason that we don't have a great handle on this is because the range of disciplines and data and communities that must be involved in solving this problem. I've listed a few of them here, and traditionally these are siloed into their own data sets that don't communicate with one another. And so it's very difficult to bring these communities together. But what we were trying to do with the CHESS project was to develop the semantic technologies and the knowledge network, as we called it, that brought all these different data sets and communities together to understand the space weather impact on the power grid. So I won't get into the details here, and you're not meant to really digest this image here, but just to give you an idea of what the backbone of the foundation for this work was ontological development. So we basically produced a new ontology for the solar event impact on the power grid. And we tried to make this sufficiently general so that this could be linked to other applications being applied in new areas. And to do that, we used a modular ontological design pattern approach. And you can read more about this in the paper here, and I'm happy to provide these slides afterwards to you. But the idea is that this was built on the semantic approach, and that's what allowed us to really make this work. But it's very important that it's not just establishing the ontology that allows this interconnection to occur. You really have to bring that to a platform or a way for people to interact with the data. And so what I'll introduce here is just the prototype that we put together of a platform for the CHESS project. And I'm going to play this video in a moment, but what you're going to see is a integration of power grid data. This is a sensor that's collecting information on the power grid, or currents that are coursing through the power grid. This is the nearest magnetometer measurement to that measurement on the power grid. And then we also include the solar wind information here, so that all of these things can be correlated and understood together and brought into one place. And what you're going to see here is we can actually understand the physical location of what's going on by clicking on one of these triangles, which would represent a power grid measurement that will pull up the station, as well as one of these green dots representing an information flow from a magnetometer. This will automatically pull up the nearest magnetometer so that someone, say, operating the power grid could quickly look at this information together and explore it so they could bring their knowledge to it and allow us to understand what's going on during any given particular event. So this allows you to select different dates, different locations, and then explore the different pieces of information that are now available. This is a radical change to how people operate the power grid now, which is with very limited information and actually no information typically about the solar wind information, but more just these global indices that are not sufficient or adequate to understand the solar wind, the space weather context. So this was a prototype platform that we have used to work with power grid operators, and it's something that they said has been a huge change in how they would look at the data and understand the data that they're seeing. So this is just an illustration of what you can do and what needs to be done with the semantic technologies, I believe. The next example that I want to talk about is an active project that we're working on now within that was funded through NASA, and it's called the Heliophysics Knowledge Network. So it's very similar in concept to the CHESS project, but in this case, we're applying this to the heliophysics domain, which crosses everything from solar energy all the way to the upper atmosphere and their impacts on the earth science. But the Heliophysics Knowledge Network is a collection of software and systems for improved information representation in heliophysics. And this is leading us into the next component, but it really is trying to be the commons for the community to use and collaborate through them. And I'll talk a little bit more about what that means in just a moment. But HelioKnow is the technological framework for a more informed, participatory, and collaborative heliophysics community. The way that HelioKnow responds to the challenges that exist is in creating a research environment by better connecting data and tools and communities for heliophysics research. And we think of this as an ecosystem. And it does this by means of the knowledge graph and connecting different graphs together into knowledge networks. HelioKnow first focuses on a very specific use case. So it's the connection between the magnetosphere, this area carved around the Earth in space by our magnetic field, and the upper atmosphere, the ionosphere, where a lot of the space weather effects are tangibly felt. So this is a demonstrable use case to develop the methods and foundation to create a full heliophysics knowledge network. So this is kind of building onto that thinking in graphs. The HelioKnow solution is to better connect the data and tools for heliophysics research, as I mentioned, and using knowledge graphs as well. And I already mentioned the use case that we really focus on with this. The final effort that I want to bring here today is something that exists within Esip itself. So we're starting to make these inroads to Esip, the Esip community, and it's something that was kindly awarded through a Funding Friday microgrant during the summer meeting, and it's following on some foundational work that the SimTech community and cluster have produced here, and particularly Ruth Dewar, in performing glossary harmonization. So the key to this is that before you can develop any of these semantic technologies, you really have to have some kind of common representation of the language. And it's become clear from the projects that I presented already that there are many different languages spoken across space science. And in order to bring space science into Esip, we have to harmonize those languages. So now what we're doing is working on this harmonization process through this micro grant, and specifically doing this within Esip. Within space weather and heliophysics, we've already compiled more than 12 glossaries, dictionaries, and collection of terms or taxonomies. And this harmonized glossary or collection of terms is the first step towards some of these more advanced semantic work that we want to do. What this funding is supporting are virtual working meetings among a focus group to harmonize these glossaries and to create the resources that permit broader co-creation of these pieces of information. So this is an area where there's very much participation and contribution we're interested in. In fact, we're going to be launching the very first phase of this project very soon. It's the learning phase of this, which is where we're going to try and teach the Esip community better how to do this glossary harmonization. And so Ruth Dewar has kindly agreed to give a talk about how she's done this for things like cryoscience. And we're going to learn from that and design how that can be done and applied to different areas of Esip as well, which is something I know that the SimTech community and cluster have talked about doing. And so I hope that can benefit some of their work as well. So the question is now, how do we connect these different pockets of progress and make them usable and really bring them to the community? And that brings me to the final innovation that I'm very interested in discussing and bringing up today. And I think it's very much a cutting edge topic. And so that's why I'm very excited to kind of have this community weigh in on this. And it's this innovation of moving from these knowledge graphs and knowledge networks to a knowledge commons. And I like to introduce it with Elinor Ostrom's Governing the Commons. I think it's a wonderful book that really illustrates how we can do this and why we need to do this. But the Nobel laureate Elinor Ostrom spoke about the need to treat knowledge as a commons or a shared resource open to all, like the environment and the oceans. So I think the principle was laid out in this quote. And again, this book is something I think everyone should read. It illustrates what's required in moving from knowledge graphs and knowledge networks to a knowledge commons. And that's the cultural components. She says, what we've ignored is what citizens can do and the importance of real involvement of the people. And so it alludes to the fact that the success or failure of a specific approach to managing common resources hinges on the match of the specific institutional arrangement, the local culture, and the particular problems involved, as well as how the approach was implemented. And so when I think of a knowledge commons, I kind of define it as the combination of intelligent information representation with the openness, governance, and trust required to create a participatory ecosystem. And so I think that's allowing the whole community to maintain and evolve the shared information space. And that's kind of where I think it is very important to move to and to have this conversation with Esip. So recognizing the pockets that I just presented within heliophysics, and I'll note again, there are many that I have not shared. I selected a few of those that I thought were illustrative. And the imperative to connect them leads to this concept of the knowledge commons. And I want to just highlight two quick examples of how we're attempting to move in this direction. And it's very much an active area right now. So these will be open-ended. The first is a center that we've now stood up within NASA called the Center for Helioanalytics. And this is a really exciting initiative. It's been going for the past 10 months or so. We've just received 3 years of additional funding. So it is really going to be a sustained center. And the goal of this is to establish a community of practice to expand the discovery potential for key heliophysics research in missions through something we call helioanalytics. And helioanalytics is simply the information sciences, the data sciences combined with semantic approaches to do heliophysics science. And so it kind of encompasses these pockets that I've talked about and really provides the link between them, but also addresses directly the community component of this. How do you actually bring the community together to focus on these things? And so I'm really excited about the Center for Helioanalytics. This is a place for people to interact with us. I'm happy to talk with you more about that here. But perhaps in the discussion, we can turn our conversation more towards this. But the evolution of this is that we're now working with a broader community about something that abstracts from heliophysics to be focused on space itself. So a much more broad effort that we're thinking of as the space data knowledge commons. So the image that you see here is just something we've published on the MIT PubPub platform, which is an open science, open access platform that the MIT community has produced. And we're actually working with the Knowledge Futures group who manages this PubPub resource to think about this space data knowledge commons. And we've started an entire new space collection within PubPub, and we encourage people to contribute to that. The beautiful thing about the PubPub platform is that you can publish a piece and then allow it to be a living conversation around that piece. We very much expect the space data knowledge commons concept will evolve, and we want it to be a very broad, inclusive, and diverse plural perspective on that. And so we encourage people to comment on this and help make that a living, evolving concept. But the space data knowledge commons is another area that is very much a broad distributed effort that we want people to contribute to. One thing that we're doing is designing workshops. They're going to be virtual gatherings that are designed by myself, a number of people from NASA, and then the Knowledge Futures group at MIT to explore the structure and produce the collective knowledge and experiment with different approaches and workflows and syntheses for this. So we're very excited about this as well. I encourage you to read the piece and help contribute to its evolution. So where I wanted to end today's short talk was here, and with the point that the Esip community has been working on outstanding resources and ideas that naturally connect to the ones that I've presented. Just looking through the SimTech cluster working meeting minutes, some of the ones that I've missed, a number of the other groups that are focused on these similar ideas, a lot of the common ideas continually emerge. And so I'm very excited to have this discussion with people today. The question is how to connect them and create an Earth and space knowledge commons. So I know this has been discussed in the past, but I suggest that the difference now is the foundation. So I presented these pockets of progress and some infrastructure that's been developed that's beginning to link them. And that now exists. And I think it provides some natural boundary navigating objects for us to connect a little bit differently than perhaps in the past. And so I think the timing and the resources are right for bringing the space-based perspective to Esip and to Earth data. I have personally many questions that I'm excited to talk about to actually do this, but I hope that we can get into those together and have a generative discussion. I guess I will finish by just leaving up here a few ways that you can contribute and open it up to discussion. I welcome people to get in touch with me, and I'm very excited to kind of talk with people about this. So again, thank you for your attention. Thank you, Megan and Esip leadership for the opportunity to speak today.
Thank you very much, Ryan. That was awesome. And I'm really excited for the conversation that you're kicking off right now. I'll note that there are a couple of questions already in the chat box, and I might encourage you, if you're willing, to stop sharing your screen so that we can see others. Hopefully, there's no pressure to turn your camera on, but certainly that will make it feel more like a discussion for those who are here.
Sure. I guess we could start with Alberto's comment. And he asked if the ontologies were publicly available. The chess ontology, yes, that's something that we'd like to get into the community ontology repository, but at this point, it's not yet in there. There's a few axiomatization things that we need to address and make sure that it can be usable in there. We don't want to put something that's not a usable resource in there, but that's an excellent question. It's something we're working towards. And I'll pause and let Alberto follow up if there's anything I didn't address or if you'd like to know more.
Yeah, okay. So the follow-up would be general interest in seeing some of these, an actual live, real knowledge graph that you might have generated using some of these ontologies when the time comes, as an example for what you're building and also how you would extend it to earth sciences and other disciplines.
Absolutely. Happy to talk with you all. For the moment, I'm going to post the link directly to the paper that we published that describes the ontology a little more. And then I can point you to some of the resources for building the platform on top of that.
Great. Thank you.
Thank you. So Megan, should I just hop through these questions first?
Yeah, I think that would be great. It looks like Michael had a question. I don't know, Michael, would you like to verbalize your question? I mean, I can read it, but.
I would just say, the idea is that this is just a very hard task, harmonizing language, information scientists. I'm in an information science department, and this is just always a problem, and we never seem to have a good solution for it. So I was just wondering what the approach was going to be if you had figured that out already.
It's a great question, and it's one that is very much built into the process that we hope to do with this. So I come from a similar place, and just that there are a lot of different ways that people have tried to do this. The best example for me is what Ruth has done with cryo, the cryo community. And so what we're going to do is start by a learning phase of the project by presenting what Ruth's done, which I think is a very successful example, and then compiling what I'm thinking of as curricular resources. So I don't think that there is a prevailing philosophy for doing this. You're right that it's very difficult. So we're trying to compile the different approaches that do exist into some really nice usable resources. We welcome everyone to contribute to that. But basically, these are learning resources for how to do this, and then choose the one that may be most appropriate to your domain. Maybe it's a combination of a few different ones, but I think it's very much open-ended at the front end of this project. I welcome you to contribute.
That makes a lot of sense. And I think that would be a useful resource for a lot of people. So
great. And I'll mention, I think I'll have to double check the calendar here. Maybe I can do it in a moment, but it's either October 9th or the week after that we're planning on doing that first learning kind of virtual workshop webinar. So I'll make sure that the whole Esip community is clued into that. Thanks for your question.
And Ryan, this is Ruth. Yes, I'm here. If you'd like me to expand a little bit, I can give the 20-second version of the cryospheric harmonization effort, because
Please do. You're much more equipped than anyone here to talk about it. So thanks.
it's really not so much harmonization, but an understanding of difference, and an acceptance of those differences. The classic example that the semantic folks here probably have heard me talk about a billion times is the term thermokarst, which, depending on what community you comes from, is either a process or a landform. Well, semantically, you can easily deal with that. You have a thermokarst process and you have a thermokarst landform. And that's just a really simple example, but it's the key is to understand everybody's different definitions, and then to see where they can be combined or where differences truly exist, and where we need to understand what those differences really are, and then basically documenting that. So that's the simple 20-second version. If that was helpful.
That's very helpful, Ruth. I was trying to find this resource. I think I shared this with you before, but kind of that similar ethos is embodied in this wordnik exercise, where it's basically trying to pull together all the different definitions in one place where you can see them, so that you can understand the differences between them, and not trying to be a definitive source on this is how that term is defined. So I think that is a very useful philosophy on it. Thank you.
So Ryan, there's a question from Claire about whether you plan to share these slides, and I might ask whether you'd be willing to publish them in the Esip fixture repository shortly after.
Absolutely, yeah, no problem at all.
Awesome. All right, Leslie is asking, for the step before harmonization, any tips or observations on how to get communities to develop dictionaries or ontologies? That seems like a bottleneck in some disciplines. Takes a certain type of person. It looks like Leslie has shown her face, so I don't know if you want to add anything to that.
Nothing to add, just showing my face that I'm here. And the thing that spurred this question is sometimes, as like in my coordination role, someone will say, well, don't you know of any seismology ontologies? And I'll be like, I don't know. There should be something out there. And I'm like so embarrassed I don't have any sort of answer or who to go to. So just what to do when there's a gap or a perceived.
Yeah, it's a really important question. I kind of go back to the conference or workshop example. I mean, anytime we go to a conference or a workshop, inevitably the first few days are everyone kind of learning how to speak the same language. And that's something that naturally happens when we gather in person. We just, by trying to do the work together, we uncover these ways that we're speaking of similar terms and with different definitions, and we kind of have to be pushed in that direction. So I guess the thing that I'm thinking of is, the really useful thing is to draw people's awareness to the fact that they're using the same terms to mean different things. And there are different ways that we can do that. So, I mean, I guess in the virtual setting, one thing I've done is just try and make it explicit, build into any meeting that I'm having, kind of define your terms and how you're using them explicitly up front. It just creates a conversation around the need for understanding one another's dictionaries. I know that's kind of abstract, but I think it's the first step is just drawing people's awareness to that, the fact that that's needed. And then it will push people to think more about that. Then the natural next question that I see happen is people are wondering, okay, well, what ontologies do exist for us to do this? And so having kind of a database of ontology repositories, you know, COR is one that's very useful that Esip's developed, but there are other databases of ontologies, even more general ontologies that are useful for the web. And I think linked open vocabularies, LOV, is something that can be used to search ontologies, things like that. But having those to point people to what's out there already. And let me search through that to see what these look like and what might be useful for my domain is also very useful. And then I guess the final point that I'll mention is this modular ontology approach that I mentioned briefly with the chess project, which allows you to kind of identify these common paths, or I think they call them trajectories through space, like maybe a model usage or a data set usage. These are common ontological patterns that all many different domains need. And so they create these modular patterns that can be moved into a new application. So I think that's a particularly valuable approach as well. And having these pieces you can pull in so you don't have to start over from scratch, which is kind of not helping build on the progress. Does that answer your question?
It's a good discussion, things to think about. Thank you.
Thank you. And for others, I'm always interested in these different ontology repositories that exist that I may not be aware of, because that's a resource that's very valuable to me too. So if you have those, please toss them in the chat. I'd love to learn. Thank you, Leslie.
So there's another comment in the chat from Stephanie, who notes that your presentation was very timely. The environmental health sciences community is currently working on building a sustainable effort to develop and adopt harmonized semantic approaches. Adoption is key. What incentives or drivers will encourage the utilization of the harmonized glossaries and ontologies that are being developed?
Yeah, it's an excellent question. The biggest incentive is just that you can't do it without it. You can't do interdisciplinary work without it. And so just recognizing kind of the way that trying to do that work fails if you don't have that first step of understanding one another's language is very important. I think in terms of incentivizing it from things like funding, there has to be you have to be an awareness of the fact that that takes a little more time to get to that point. And so I really am encouraged by funding for interdisciplinary programs that naturally understand that, and just making that a part of the process itself. I would love to hear from others too. There are people on this call who are probably much better equipped to talk about this than I. Pierre has his hand up and I'd love to hear what he has to say too.
Megan, is that okay?
Absolutely, yes.
Okay, I wait for Megan's authorization on all things. No, right. So I think that's, that is key adoption. But, we've seen this in semantic web for a long time. We've seen this in many initiatives that becomes a kind of free for all in some time, and it's kind of disruptive. So what's actually happening through work that Ruth has started with the semantic harmonization and things, it's becoming more encouraging to people adopting things when they know those resources are actively trying to harmonize with other resources. So it's not like use mine or use mine. It's that they are building that commons, they are mapping to each other, they are figuring out what they do better than other resources and where they're weak so that they point to the resource that fills that gap. That kind of honesty, that sort of transparency, and actually building the interoperability between the resources themselves is much more encouraging for adopters. They're like, okay, I know if I use this, I can also then hop over to another one because they're doing the work to align it with the relevant experts. And I think that's very, very encouraging and scalable.
Yeah, actually one question I'll pose to the group, and Pierre, maybe you have some thoughts on this, but how do you, I guess funding is often tied to these metrics or these however we quantify that moving between, or the value of these different ways of going between these communities is interoperability. That's a very difficult thing to quantify, and we don't really have great metrics for that. So it's hard to show a funder that it's valuable. Is there some way that you see someone doing that well in the community, kind of almost quantifying the importance of interoperability?
Quantifying it is tricky, but particularly because funders are not really evaluating it on that basis yet. I think there needs to be some capacity development on the funder side to be able to say, yes, this is a good investment because it's interoperable. That being said, you can see that one resource has made efforts to interoperate with another. For example, the ontologies inside the semantic harmonization, they either cross map to each other on the terms, like the cryosphere terms, hopefully others, hopefully space, weather now, or they produce artifacts where there has been an expert mapping between the two. I'll drop in an example from the biodiversity community where we used a triple SOM mapping, which we want to also use in the semantic harmonization cluster. And you'll also see like there's a narrative around that about how to sustain it. So it's not just a one-shot thing, it's really bringing communities together to agree to sustain that, a kind of memorandum of understanding thing. Ruth, probably you have some perspectives there too, I would assume.
I was just going to comment that this is exactly what's happening in the NASA SMD project at this time, is trying to come up with metrics. And our zero order metric is something called the infinity metric. It's called if your solution allows you to do something that was impossible before, then it's obviously shows some value, and it's just called the infinity metric. For example, right at the moment, there is no place that one can go, not even Google data or data.gov, to get heliophysics data and NASA's gene lab data together. But one of our first use cases involves effects of heliophysics solar activity, basically solar particle events, SPEs, on critters on the space station. And so by definition, you have to bring those two things, at least those two things, together. And so that's the infinity metric. Can you do something you could never do before?
Oh, very cool. I love that. Does anyone else have an example of a metric that they're aware of, or some way of thinking about this that's helpful? I think it really is kind of a threshold question. Maybe we can let it sit and simmer with people for a bit. I know that Pierre, you had another thought here of whether this would be another semantic harmonization cluster activity. I'd love for it to be. I know that that group is taxed already with a lot of different projects and things they want to focus on, but I would love to have that community think about this.
Or maybe even just set up another community to do it, so that it's not, we want it to scale, right? We want other people to learn from us. And after the cryo hackathon series for the cryosphere harmonization, we're writing up that paper now, especially the materials and methods to reflect on how we managed to do it, what lessons we learned, and how we're going to do that now for hazards and disasters. And I think that's actually a natural overlap. We could start with a coronal mass ejection hazard/disaster, and like maybe do a demonstration case there with your community, and perhaps set up a group there. Again, the nice part of the semantic harmonization is that we're focusing on the phenomena themselves, and then whoever's at the table, whoever develops whatever semantic resource, aligns to one another. So we know that that phenomena is covered by multiple resources, and they all agree on they all agree that it has been covered to the best of their ability, and they cross-map to each other. So then users can hop across whichever one they need based on their implementation needs. Sometimes you need a vocab, sometimes you need a ontology, etc.
I really like that idea, and I think that the Chess Foundation could provide a nice lead into that. So hopefully it could, we don't have to start from scratch. I don't see any other questions, but I did want to raise one to the group, if that's okay, Megan.
Yes.
Let me see if I can find the discussion piece. Okay. So I'm just going to share my screen again. So this is something that I'd be interested to know from people, both from non-semantic technology experts and from the SemTech group that are represented here. But it's a matter of this kind of finding the more common language. And I think, we're seeing semantic technology be increasingly identified as a solution to a lot of the problems that we face. But I'd like to bring those groups closer together. And this is the question I came up with, which is focused on the term or concept that the other group that ought to be known more about. So for the non-semantic technology experts, what's a term or concept that you continually see or that you're curious about that you think is more important for you to know about? And then on the other side, for the SemTech experts, what's a concept from this domain that ought to be more widely known?
So this is Stephanie. Hi, Ryan.
Hi, Stephanie.
I'm with the National Institute of Environmental Health Sciences. And this is it's fascinating because you're touching upon a lot of the topic areas that we've been having as part of our own internal discussions, as well as with our larger community, especially since we realize that one of our objectives for the collaborative that we are looking to develop needs to cultivate a more vocabulary aware research community. And it became apparent to us as we were putting together materials that our non-semantic audience didn't like the word semantic, and we're needing to do a better job of trying, and everything that we were using in our communications, the irony was not lost upon us. What word do we use to describe what we're doing? And we used harmonized, we used common, we use standardized, and then is it a vocabulary? Is it terminology? Is it a language? Is it, semantics? And we wanted to use semantics, and we're getting a lot of pushback from our community advisors that that's a scary technical word and people will be turned off by it. And my justification was, well, at some point we want to get them to be comfortable with it, and so you have to start using it and defining it for them. Knowledge graphs was also another area that came up where we had some small use case working groups, and in one of those, one of our more data science interoperability experts was talking about how they are developing knowledge graphs. And there were actually several subject matter experts on the call who had never either heard of knowledge graphs or had heard of them but didn't really know what they were. And so those are just two examples from our experience that might be worth including as concepts that could be expanded upon further to raise awareness and give the non-semantic folks some background.
Thanks, Stephanie. That's really helpful, at least for me. I'd love to tag up offline too, to hear more about your efforts for the collaborative.
Yeah, we also created a graphic that, there's tons of them out on the web, but we, I guess you could say, customized it to use examples from our various disciplines and fields. So you have of course, the semantic, well, sometimes it's shown as a hierarchical flow between control vocabulary and taxonomy thesaurus up to ontologies, right? And so we created ours more as it's sort of a visual thing. I'm trying hard to describe it, but it really was a very actually there's two graphs to it. The first is showing what are the differences between a thesaurus and a taxonomy, an ontology, control vocabulary, etc. Obviously, there are a lot more terms that you can include in there, like glossary. And then showing what the benefit or the value is of using that one versus another one, and then giving examples so that that abstract concept can then be solidified by having examples. And then we explain to people how the ontologies, for lack of a better word, provide that foundation or the backbone for the knowledge graph, so that we could then, show how the knowledge graph basically is taking that ontological framework like you were showing, but it's actually being populated with real data so that you can ask research questions that you wouldn't be able to answer right before all of those disparate pieces of information were collated together. So I'm happy to, I see that there's a request to kind of see those graphs, and I'd be happy to share those with you. Maybe I'll send them, I guess, to Megan, and then she can distribute accordingly.
Sure. So I think, Ryan, we're coming to the end of our hour together, and I feel like there's so much more we all should discuss. But I think one kind of thread of things that's left here, and maybe I'm being selfish in bringing the thing that I'm most curious about, but how, and I think you have this question yourself, how do some of the things that you are talking about relate to some of the things that are going on in Esip right now? And what are the main touch points? I'm also curious from, maybe from Pierre and Ruth, where does the Serene Federation concept fit into all of this? And I think it's okay if we go a couple minutes past the hour, but I'm going to try to wrap us up pretty fast after a little bit of discussion on this topic.
Right, so I mean, oh, go ahead.
Please, Pierre, go ahead.
In terms of like the Serene, so Serene was an idea to create a registry of semantic resources. That's what it stands for, semantic resources for Earth and environment. And it's a registry of all semantic resources. We have core, which has functions and things for the terminologies, so the vocabularies, etc. And this is more just a very lightweight registry, similar to what the Obo Foundry did for all of their semantic technologies and assets. And it's just a way for us to keep track of who's doing what. So from knowledge graphs to tooling to web services, etc. Because I think that's something the earth science and probably the space science community can benefit greatly from. Just a nucleus for that, on top of which people can build portals, etc. We're not aiming to build a new portal or anything, just keep track of things, right? Keep track of things openly on GitHub so people can do pull requests and add things for visibility with very light review. So that's the idea, and I think that's speaking to a lot of what Ryan put forward. It's that you get very focused groups generating wonderful solutions, and then comes so they've shown that it can work, and then comes the challenge of how do we get it to interoperate with others. Then you have to look for who else is doing that. And there isn't really so many places to look for things other than the terminologies that core and other aggregators offer. So I think that's what we're trying to do there, and just catalog that more transparently so that we can foster some more collaboration.
Yeah, thanks for explaining that, Pierre. I haven't been as closely involved in Serene. I'm very, very excited about it. I'm gonna definitely dig a little further into it. One of the things that was a challenge for me was just going into the Esip collaboration page and not seeing a cluster for Serene. So I think it right now in the moment it exists within the SimTech work or cluster, or where does it exist?
Yeah, it's a kind of hybrid, right, Megan? It's something because it's more like a project, but at the same time we're trying to get a separate meeting for it, and I think there's some organization. It's very quiet. It's just a concept right now, but the Polar community has agreed to add some resources there as a trial, and then we'll build from there. Yeah,
it's always a challenge. The Semantic Tech Committee is sort of an umbrella for lots of other activities that may or may not have an official cluster that sits underneath it. It's a challenge because we want to direct people to the right place, but then by creating more places, we have to figure out where to direct them to. So that question of whether to spin off an official new cluster versus to make it an activity of the umbrella cluster or committee is always a challenging one.
I think we need to get some content in the repo first, and then I think it'll be more compelling, shall we say, to figure out what exactly it is. I mean, we know what it is. It's a project to list things. We have some ideas, but we need some examples in there to motivate others to add their content.
Thank you very much, Pierre. I guess, Ryan, do you have any last words you'd like to say? We're sort of at the top of the hour. I'm going to give one brief closing slide, but I wanted to see if you have any last words.
Just that I'm very interested in continuing these conversations, and some of the cluster conversations are probably great places to do that. So I'll be joining those, of course. One thing that I will put up, we didn't really get into a lot of this, but it's actually how to do that kind of cultural piece to this. And I kind of divide those into a few different areas that I'd love to be future areas of discussion in terms of just platform development. How do you generate trust in the resource? And then how do you govern that resource? And how do you allow that to be kind of co-governed in a community kind of collective governing of that? But I won't get into those issues right now, just kind of putting that out there for people to think about.
All right, I have taken the screen share back, I believe. So thank you again, Ryan, very much for speaking today. And thank you to all of you for very generously participating or contributing your thoughts and questions. Again, this is a to be continued kind of thing. So I'm glad this has been kicked off and it's by no means finished. However, this does conclude our time together today. We will be back on October 29th at 2 p.m. Eastern time with the next installment of the webinar series. We'll be featuring Dr. Fernando Perez, who created IPython and co-founded its successor, Project Jupyter. The title of the webinar is still forthcoming, but it should be another awesome webinar as well. A final note to stay up to date on all things ESIP, including the announcement, a more official announcement of our next webinar and updates on the upcoming January meeting, including the call for sessions. Please subscribe to our Monday update mailing list. You see the bit.ly on the bottom left here. And finally, a note that this webinar was recorded, will be posted to YouTube shortly. I will also make sure that the slides are published and shared along with the recording. Thank you, everyone.